6.1 homework on antiderivatives. Going backwards, we're finding big F, we'll call it big F, which we say is the antiderivative of F. This is the notation for antiderivative. We'll take the antiderivative of F. We'll remember that you can have a C whenever you're taking an antiderivative, because if you take the derivative of a constant, it's always 0. So if I go backwards, I need to be able to account for these constants that may or may not exist. Okay, so I'm going to take the antiderivative to get F, and for these I'm going to use the power rule. Now the power rule for antiderivatives, it's like the backwards power rule for derivatives. We are not going to bring, so let's think about derivatives. We bring it down and then subtract 1. So the derivative would be 5x to the 4th. Instead, what we do is we add 1 first, so this becomes x to the 5th, and then multiply by the reciprocal, which would be 1/5. So I'd have 5 times 1/5, x to the 5th. That's how I would take the antiderivative to get x to the 5th. But from x to the 5th, I would have to add 1 to get x to the 6th and multiply by the reciprocal, giving us a 1/6. You can always check by taking the derivative. The derivative of 1/6 x to the 6 would be, okay, 6 would come down, multiply by the 1/6. That's just 1, x to the 5th. Okay, that's good. The rest are the same. Add 1 first, then multiply by the reciprocal of your new exponent. Add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal. Then I get down to 1. We know that the derivative of x is just 1. The derivative of 3 would be like 3x. The derivative of 10x. But then we can't forget that if I have a c here, the derivative of c, a constant, would be 0. So we need to incorporate this c, because if I took the derivative of big F, I would still get F, even no matter what number this is. Okay? Now, for all those, didn't work out nicely. For these, watch how these actually work out really nicely. Okay, add 1, multiply by the reciprocal. All right, so that 5 gets multiplied by 1/5. That's how I know I'm going to have just x to the 5th. I'll just do like 2 steps here. So x to the 4th times a 4th times a 4. X to the 4th. X cubed times 1/3 times 3. The 1/3 and the 3 cancel, just gives you x cubed. X squared times a half, the half times the 2, just 1. So this is just x squared. The 1 is x. Don't forget the c. Okay? When we're dealing with roots, any type of root, we need to be comfortable writing it as a fractional power. This is 2x to the 1/2. This is 3x to the 1/3. This will be 4x to the, okay, so that's x squared rooted. I'd write that as x to the 2/3. You can take a power to a power and multiply the powers. We should know that exponent rules. Okay, now taking the antiderivative, add 1. 1/2 plus 1, that's 2/2, gives me 3/2. Multiply by the reciprocal, that's 2/3. Multiply that by the 2. That gives me 4/3 x to the 3/2. Here, 1/3, I have to add 3/3. So this becomes x to the 4/3, then multiply by the reciprocal. Then we can multiply that 3 and the 3/4 to give us 9/4. 3 divided by 1 times 3/4, 9/4. Okay, I'm going to add 3/3 again. So that's 5/3. 3/5 times 4, 12/5. Don't forget a plus c when you're taking the antiderivative, because the derivative of c would be 0. Trig functions, the best way to deal with trig function is just to kind of think about going the opposite way. If I think, okay, cosine x, 3 cosine. Well, think about it. If I took the derivative of cosine, the derivative of cosine is negative sine. So the derivative of 3 cosine should be negative 3 sine, but I want it to be 3 sine. This is why I need a negative cosine, because the derivative of negative cosine will be positive sine. Let's think. Cosine, it's really tricky going backwards with sines and cosines. You really have to kind of concentrate and be able to think about, checking by taking the derivative. If you look at 2 sine, the derivative of 2 sine is 2 cosine. Okay, that works out. If I thought it was the opposite, well, I would be wrong. 2 sine, that's negative. Its derivative would be negative 2 cosine. So that's it. Just 2 sine, and then don't forget a plus c. And don't forget about this constant, right? We recall the constant multiple for derivatives. It's the same with the constant multiple rule for antiderivatives. The derivative of a constant times a function is just the constant left alone times the derivative of the function. And then the antiderivative of a constant times a function is just the constant times the antiderivative of the function. Same deal. Yeah, I'll put that there. Sure. If we have exponents in the denominator, similar to how we, would take derivatives, probably the easiest way is not to use the quotient rule for derivatives. The easiest thing to do is to rewrite this using negative exponents. Okay? Now, be careful. You're adding 1. So it's not going to go to negative 3. It's going to go to negative 1. Multiply by the reciprocal, that's just negative 1. Adding 1 becomes negative 2. Multiply by negative a half, so 2 times negative 1/2 I'll have to do. And then this becomes x to the negative third. Multiply 3 by negative 1/3. Don't forget a plus c. We'll write that out all simplified. Negative 1 over x minus 1 over x squared minus 1 over x cubed plus c. Okay, let's try this. I put these in here just so that we know, because a lot of students make errors on this. If you're going to move the x squared, the 3 doesn't go with it. Okay, the 2 stays, the 3 stays. It's just the x that gets changed to the negative second and moves up. So don't move the 3 with the x squareds up. 3 stays. The 3 is not taken to the second power. It's just the x that's being squared. So this is 3/4 x to the negative third, 5/6 x to the negative fourth. Let's take the antiderivative. I'll go one step at a time. This will be x to the negative first times negative 1 times the 2/3. This will be x to the negative second times negative 1/2 times 3/4. This will be x to the negative third times negative 1/3 times 5/6. Don't forget a plus c. Simplify. Negative 2 over 3x. Okay, you can move the x down. You don't have to write it as 2/3 times 1 over x, because the 2 times the 1, the 3 times the x. Boom. This will be negative 3/8 x squared on the bottom. So I could have said minus. Minus plus a negative. I prefer plus the negatives, honestly. I feel like sometimes students do minuses more than I do, which pushes me to do minuses, but I like plus negatives. I think they will prevent mistakes. It's negative 5 over 18 x cubed, and we don't forget our plus c. Okay, so if I took the derivative of this, I would get this. And you can always check by taking derivatives, especially for your quiz. Check by ddxing, taking the derivative. Okay, if you ever see something like this, know that there's no product rule. There's no quotient rule for antiderivatives. It's a lot more complicated going the other way around. So the antiderivative of this is not like, I'm sorry, it says evaluate the integral. Let's make sure we understand that this notation means take the antiderivative. Okay? Now, if you say, oh, add 1 multiplied by the reciprocal, add 1 multiplied by the reciprocal, choose the antiderivative of 2x, you're wrong. Okay? Not correct. You must simplify first and use the power rule because there is no product rule or quotient rule for antiderivatives. There's another technique we will learn in the future. We won't learn it right now because it's not that important right now, but there's another technique we will learn that might be able to help us for situations kind of like this. Now, you'd say this is just equal to, there's no other, big f of x or anything. It's just if you take the antiderivative of this, you get this. You can't, we'll talk about how you can take the antiderivative of this next class in a different way. But for right now, the best way for you to understand what to do is to just simplify. Make sure we know how to square 2x plus 3. We'd have 4x squared, 6x, which is 12x, 3 and 3, which is 9. Add 1, multiply by the reciprocal. Add 1, multiply by the reciprocal. Antiderivative of 9, 9x. And then I get a c. And then I can simplify it. Now, many of you will start to get used to this process, and you will be able to skip this step, this middle step, before the simplification. Okay, same here, we got to simplify first. We need to be able to multiply root x by x squared. The way I'm going to remind you how to multiply root x and x squared is what is x squared times x cubed? Is it x to the 6th or x to the 5th? It's x times x times x times x. There's 5 x's being multiplied. So we just add the two exponents together. So if I have root x times x squared, I'm going to add these exponents together. This is the same as 4 halves, so this becomes x to the 5 halves. And this is very, very important that you know how to do that. If I have x to the 1 half times x, that's 2 halves plus 1 half, that's x to the 3 halves. Taking the antiderivative of this, add 1, that's 7 halves times 2 sevenths. Add 1, that's going to be 5 halves times 2 fifths times 2. Don't forget your plus c, 2 sevenths, x to the 7 halves plus 4 fifths, x to the 5 halves. Let's see. Okay, same deal here. X to the 1/3 times x squared. X squared will be x to the 6/3, so I'll get x to the 7/3. X to the 1/3 times x, that's 3/3, that'll be x to the 4/3. Take the antiderivative of this, add 1. That'll be x to the 10 thirds. You know, add 3 thirds, multiply by the reciprocal, 3 tenths. Add 3 7 thirds times 3 sevenths times 2 plus a c. So I got 3 tenths x to the 10 thirds plus 6 sevenths x to the 7 thirds plus c. All right. If you see a quotient, you cannot use a quotient rule. There is no quotient rule for antiderivatives. Instead, you need to divide. Now remember, when you're dividing, you know, either you're going to be subtracting your exponents, because like you have so many x's over x's that you can cancel, which just like removes 2 and just leaves 1 in the numerator. It'd be the same thing here. I'd end up with 3 x's in the denominator over 1, or you could write it as x to the negative third, which is probably what we're going to want to do anyways, so that we can then take the antiderivative using the power rule. So remembering that, remembering if you have 2 items divided by one thing, you can divide both of those terms by this one thing. Probably what would be best is to, maybe not. Let's just go ahead and divide both those terms by x. You'd have x squared plus x. Antiderivative, add 1. Multiply by reciprocal, add 1. Multiply by the reciprocal, plus c. This guy, again, before I try to simplify, I got to understand dividing by x to the 1/3. So x cubed divided by x to the 1/3. Well, it's just subtracting, right? So might as well make this x to the 9/3, not 6/3. That'd be x squared. X to the 9/3. Divide that by x to the 1/3, and you'll get x to the 8/3. Okay. So simplifying x to the 8/3. Plus, see, x to the 4th, x squared over x to the 1/3. That's x to the 6/3. Subtract x to the 5/3. Okay, add 1. It's 11/3. Multiply by the reciprocal. Add 1. That's going to be 8/3. Multiply by the reciprocal. Don't forget a plus. Okay. Now, these are some tricky trig ones. Just know that like most of the trig guys should be set up in such a way so that like, oh, secant tangent, I know the derivative of secant is secant tangent. So like I literally just say, okay, this is the only thing I can do. It's like I need this to be set up in such a way so that I know, you know, a function whose derivative is that. There's no like fancy way to do these trig functions. Like you think like, I don't know a derivative I don't know a function whose derivative is tangent x cosine x. So this is one where we're going to think, hey, maybe we need to simplify. Simply simplify. So watch, I'm going to rewrite this, and this is a little bit of like trig simplification work here. You realize that tan x cos x is just equal to sine x. And then the function negative cos x plus c will have a derivative that's sine x. Okay, so that's kind of what I want you to do. Like 1 over sine squared, we should know that you can rewrite this as cosecant squared. Now you got to remember, the derivative of tangent was secant squared. The derivative of cotangent was cosecant squared, but the derivative of cotangent was negative cosecant squared. I have a positive cosecant squared, so that means that needs to be a negative. Cos over sine squared, let's see what this is. I mean, maybe I'm going to write this as like cosine over sine times 1 over sine. And then I have cosecant x cotangent x. And I got to remember that the derivative of cosecant was cosecant cotangent, but it was negative, so this needs to be a negative. A little tricky, okay? But cool. Those are antiderivatives. Now, what can we do with these antiderivatives? Well, for pretty much the remainder of the unit, our goal is to solve differential equations. So we will have situations where we will know like the growth of something, but we won't know like the function that gives us that growth. We will know the tangent slopes of something, but we don't know the function that gives us the tangent slopes. So we will have situations, and this is common, where it's like, hey, what's the original equation? And that's what it means to solve a differential equation. Find the original function and what it's equal to. Find the equation. And we're given information. We're given a point. We're given the derivative. So let's do it. Let's first take the antiderivative. F prime's antiderivative would be f. I'm going to add 1, multiply by the reciprocal. So I got 12 times 1/4. I got 2x. And then, yeah, I can't forget this plus c. Let's simplify a little bit. I get 3x to the 4th plus 2x plus c. But this is what we call a general solution, because it has a plus c. But we will use this point to find c. Now, the goal is not to find c. Like, finding c is part of the goal. The goal is to get our equation. Okay, so I know if I plug in -1 for x, I'll get 6. I like to kind of write it this way. So I'll plug in -1 for x. So 3 times -1 to the 4th plus 2 times -1. It's coming back. 3 times -1 to the 4th plus 2 times -1 plus c. And then I can solve. That's 3 minus 2 plus c. 1 plus c. C is going to be equal to 5. And there is my solution. F of x must be 3x to the 4th plus 2x plus 5. This function has the point -1,6, and its derivative is 12x cubed plus 2. Okay, so we did it. And that's what we're going to be doing for the rest of the problems, is like finding this original f given this information. Okay, antiderivative, this is x cubed, the 1/3 times the 3. We should be able to skip this step after doing enough of them, so that we get x cubed minus x squared plus c. Don't forget your plus c. F of 2 equals 3, so that'll equal 2 cubed minus 2 squared plus c. 3 will equal 8 minus 4 plus c. That's 4 plus c equals 3. C is equal to -1. My solution, f of x, equals x cubed minus x squared minus 1. Okay. Asking you to find a value. Find f of 2 given f of 0 is equal to -1. It's really the same thing as we did the last two situations, just with an extra step. We're going to have to find f of x, and then we'll just plug in 2. So we'll take the antiderivative first. Add 1, multiply by the reciprocal, multiply by that 6. Don't forget the plus c. F of x equals 2x minus 2x cubed plus c. I'm told that f of 0 is -1. So that's 0 minus 0 plus c. C is -1. So my function f of x equals 2x minus 2x cubed minus 1. And now I have to find f of 2. This is my goal. F of 2 will equal 4 minus 16 minus 1. So that's negative 12 minus 1, which is negative 13. Okay. This one shouldn't be that bad. I have negative 6x squared plus c. Told f of 1 is 4. I got 4 equals negative 6 plus c. c is equal to 10. F of x equals negative 6x squared plus 10. F of 1, oops, sorry, I already have f of 1, it's 4. F of 2 equals negative 6 times 4 plus 10. F of 2 will equal negative 24 plus 10 is negative 14. Cool. 2, that's a good one. The next two are called second order differential equations. We're given f double prime. That's a mistake. This should be f. Sorry about that. Now, what we're going to have to do is go from f double prime to f prime to f. And along the way, plug in information I know to find the correct equation for f. So f double prime to f prime. So take the antiderivative, I get 2x plus c. I'm told f prime of 1 equals 2. So 2 plus c, c equals 0. That's nice. So f prime of x equals 2x. Now we go to f of x. We get x squared plus c. Now it's important to find c along the way. You can't kind of like throw them in at the end. F of 1 equals 3. So it's 1 squared plus c. c will equal 2. So my solution will be x squared plus 2. There you go. This is right. Okay, second order. Let's find f prime first. 4x. Let's see. Positive cosine derivative will be negative sine. Okay, good. Told f prime of 0 is 2. So 4 times 0. Oh, don't forget that guy. Plus cosine 0 plus c. So I get cosine of 0 is 1. C will equal 1. So I get f prime of x equals 4x plus cos x plus 1. Now I take the antiderivative again. Add 1, multiply by the reciprocal, so 1/2 times 4 is 2. The derivative of sine is cosine. The derivative of x is 1, and then I have a c. And now I'm told f of 0 is 5. So 0 plus sine 0 plus 0 plus c. Sine of 0 is 0. C is equal to 5. And that gives me f of x. F of x equals 2x squared plus sine x plus 5. F prime is secant squared. F is tangent. Plus c. F of pi over 4 equals 10, which equals the tangent of pi over 4 plus c. Tangent of pi over 4 is 1. C is 9. F of x equals tan x plus 9. Find a function, f of x, that has a horizontal tangent at 2, 1. Okay, so this is just another way of saying when x is 2, f prime of 2 is 0. We should be able to know that. You know, horizontal tangent, it's the slope of 0. Horizontal tangent, f prime is 0. So then we see we are given the point 2, 1. That's a good question. So this statement gives us two pieces of information. So that way we can go from f double prime to f prime. We could find f prime. Sorry, that should be 0. C. We could find f prime of 2. It's 0, which is going to be 4 plus c. So c's got to equal negative 4. So f prime of x equals x squared minus 4. Cool. And then f of x will have to be x cubed times 1/3 minus 4x plus c. F of 2 equals 1. We'll finally have some fractions to work with. 1/3. 2 cubed minus 4 times 2 plus c. So 1 equals 8/3 minus 24/3 plus c. It's negative 16/3 plus c. 3/3 would be 19/3. So my function f of x is 1/3 x cubed minus 4x plus 19. I know the second derivative is going to be 2x, because the first derivative will be correctly x squared minus 4. The second derivative will be 2x. But watch if I graph. I'll use my new friend Desmos. One-third x cubed minus 4x plus 19/3. Ha ha ha. 2, 1, horizontal tangent. Second derivative is going to be 2x. Gosh, that's great. Great, 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 great. All right. That's it for Unit 6, Lesson 1.